Okay, so yesterday we were looking at two secants. And the two secants, I told you that we did the outside piece times the whole secant. So like BP times AP equals the outside piece, DP, times the whole piece, EP. Well, we're going to twist it up ever so slightly today. And what we're going to look at is we're going to look at like one secant that meets with a tangent. So like just barely touches the circle one time, goes on the outside. And I'll tell you this, it's pretty much the same formula as what we did yesterday. So if you look at the diagram below, AP is a tangent. Tangent that meets the circle at one point, that point is A, right there. So that's a tangent. It doesn't go inside the circle. And the secant, of course, is PBC right here, because it goes from inside the circle there, goes outside to point P. So I told you it's the same exact formula, and it is, because it's the outside part times the whole thing. But then if you look at the tangent, well, it's the outside part times the whole thing, which is the same thing because the whole thing is outside. So what you do is it's tangent squared. This distance squared equals the outside part of the secant times the whole secant. Basically the same as yesterday. So let's look at the problem we have here. In this problem, we know that PB is 4 and BC is 12. And we need to find PA. Okay, easy enough. So what we do, the tangent right here, squared. So the tangent squared is, of course, x squared. And then that equals the outside part of the secant, which is 4, times the whole secant. Well, we don't have the whole secant. Oh no, what could we possibly do? Yeah, just add it up. The whole secant is 16, 12 plus 4. So 4 times 16 gives you 64, equals x squared. When you take a square root on this, x equals 8. So PE is 8.